Hello judges, I am pleased to present BOLTZ. Since online education began, students' learning has been severely affected. As students become more and more disengaged with online schooling, we are witnessing the impending extinction of our generation's education. After multiple surveys, we found that 87% of students got distracted on a regular basis during online schooling. Our team decided this was a problem we needed to address.
BOLTZ is a Chrome extension aimed at secondary school students and teachers that helps students stay engaged during online lessons and helps teachers make sure that their students understand their work. Before a lesson, teachers will enter a few questions that they would like to ask their students and will also be able to decide when the questions will be asked. A tab will pop up when it's time for students to answer, and students will be ranked depending on how quickly they answered and if they were correct. After the lesson, teachers will be able to easily see the results of their students.
The market for education technology is increasing rapidly as a result of students having to learn online. According to reports, the UK edtech sector alone is expected to reach a whopping £3.4 billion by 2021. By the end of the first year, we aim to be in 15 secondary schools and 100 by the end of this second. We will have two main streams of revenue, one from schools and one which will come from students. The schools-based one will be a subscription plan, where schools will have to pay £5 per teacher every term. The students will make a one-off payment. Students eligible for free school meals will not have to pay. Our outgoing costs will go towards advertisement, hiring developers, and also paying Google a small fee.
Through helping motivate students during online schooling, we are providing a higher quality learning experience, hence enriching the education of millions worldwide. We recognize an issue with labeling students with bad reaction times or with ADHD as supposedly bad students. Through developing the clustering algorithm, we can incorporate more features to ensure these challenges are recognized by teachers. During an online lesson, questions on the lecture's content will randomly pop out at times selected by the teacher beforehand. If a student gets the answer correct, they receive points and are placed on a leaderboard. There are also options for teachers to send out random click ASAP screens to ensure students are concentrating. At the end of the lesson, the podium places will be presented and students will rate their class. Then the teacher can see the students' results and, by using our clustering algorithm, identify which students need help the most. Here we have our clustering algorithm. We have fed it sample data, which we later scale to fit between 1 and 0. And we have trained it using this scaled data to produce the best results. We have assigned each data point to the nearest centroid, a process which establishes which cluster each data point belongs to, helping us identify the average time students took per question and how many points they received, which can be seen by this graph here. This is our team.